Hello and welcome to Vivek Learns. So in this video we are going to start with the first question of level 1 PEP coding, which you can see from here of the grading system. Okay. So let's first try to understand the problem statement. So here let's read the problem statement first. You are given as input marks of student. Display an appropriate message based on the following rules. For marks above 90, print excellent. For marks above 80 and less than 90, print good. For marks above 70 and less than 80, print fair. For marks above 60 and less than 70, print meets expectations. For marks less than 60, print below par. Okay, so let us see the kind of inputs, the sample inputs and outputs that we are getting. Okay, yeah. So the basic thinking behind this problem is to check if we can have a command over the conditional if else statement that we have. Okay, so we will try to solve this problem using if else statements, and we will also have else if statements that we have to give these additional conditions that we have. Okay. So let's start with the coding part. So I have created this project called PepCoding Level 1, in which I'm going to start coding right away. And let me create a class called grading system, which of course has a main method and which takes input as the marks. Scanner. Scanner is a class using which we can take inputs. So let me have an instance of scanner created. So we will typically get the input from the keyboard, right? So we have to put an input source here for the scanner to know that. So from where do we get the particular input? And using this scanner, we have methods on the scanner, like one of which is nextInt, which will give us an integer that we input and let us capture that integer in a variable called marks. Okay, we format it quickly. Yep. And let's start with the if statement first. The first condition that we have, right, is for marks above 90, we should print excellent. For marks above 80 and less than 90, we should print good. Okay, so let's see for marks above 90 is out excellent, excellent. Else if I think there's a space between else if the marks above 80 and marks less than equal to 90, right? Let me check once. We have less than equal to 90, print good. For marks above 70 and less than 80, print fair. 60 and 70. Okay, so we have this less than equal to, so you have to keep that in mind and code. Okay, so why isn't it giving me an the and. Mm, Hopefully this works. And for marks above 80 and less than equal to 90, we have to print good. And let us try to have similar kind of statements here. For marks above 70 and less than equal to 90. We have a condition for marks mm, below 70, right? That is below 60, less than equal to 70. We'll have one condition. So good, fair, meet expectations. Okay, left of right. Oh, the excellent E is small. The good, fair meets expectations. Expectations. Else, I think that's the range remaining, right? Okay, let me check again. For marks above 60 and less than 70. 60 and less than 70, right? For marks above 70 and less than 80. Marks above 60 less than, okay. Okay, so the only marks which will be remaining now is the marks less than 60, which will print below par. So let's give an input statement here first. Like, how will you come to know that what we have to input? Enter marks. So we'll enter the marks as soon as we see the statement. Okay, and let's go over um, the logic once more. Like, if the marks are greater than 90, we have to print excellent. Between 80 and 90, good. 70 and 80, we have to put fair. 60 to 70, we have to put meet expectations, and so on. Okay, let's try to run this. Yep, which says enter number. Let's say we enter 94. Okay, I think this is the wrong program which got executed. My bad. Run it as a Java application, and let me put 94 right here. Okay, good. We try again with 52, which is below par, and one of the conditions which meets, let's say 77. So 77 will come in this range, right? So it should put fair, right? Okay. So that was all about this question. And now let's go to the next one. So typically you can identify a question if you see this icon here. So let's go to the next question, which is this one: is a number prime? Let me open it in a new video, in a new tab, sorry, the video. Okay, let's read the statement. You have to check whether a given number is prime or not. Take a number t as input representing count of input numbers to be tested. Take a number n as input t number of times. Okay, and each of the input n print prime if the number is prime and not prime otherwise. So we have to take an input t first. Okay, and t is basically the number of times we are going to get the input, and after that we have to iterate over all those numbers, and we have to check if those numbers are prime or not. So before understanding or going to the coding part, let's understand what are prime numbers. So a number is called a prime number if it's divisible by 1 or the number itself. So let's consider some examples, right? So like 3. 3 is a prime number because it's divisible by 1 and 3 itself. Let's consider 6. 6 is a composite number, like a non-prime number, because it is divisible by 1, it is divisible by 2, it's divisible by 3, and at last it's divisible by 6. Right? So you can consider prime numbers as the one as the people with whom you can consider them as people are who like don't like to interact with others or try to mix with others, right? They are by themselves, right? You can consider kind of an analogy here to get a better understanding and remember what are prime numbers, right? So let's start with the coding part. Let me open my okay prime numbers. Let me copy these statements to avoid the hassle of coding, of writing, enter a number, right? Because that is what we are going to do now. Okay, so we get a number which will be the times, right? The first number will be the times. Okay, so we'll capture that. Next int. This will give the times that we are going to iterate. Okay, so for I is equals to 0. So for all these times we have to take the input. So I'll have okay, let me then we will take this as the input, right? Okay, as num, right? And we need to check if this num is okay. So what we can do is we can have an array and we can have the input element stored in an array and we can iterate over the array. So let's try to do that. Input array is equals to new int and the size will be that of the times, the int times that we get, and we will have a variable here, final variable called length. We'll be iterating over this array to the number you want to check for prime, and then we'll take the input as input array of I. Okay, okay, let me copy this. I do make a lot of typos when typing is equals to sc dot next int. Scanner is the variable, right? My bad. So we take it as input, and then what we do is we try to iterate over that array again, which has the input elements, and then we try to check if the number is prime or not. So let's go with the basic brute force approach that we have here. So a number is prime, like I explained here, if it's divisible by 1 and the number itself. So typically we have to print if the number is prime, and we have to print prime if the number is prime, and we have to print what what do we have to print? Not prime if otherwise, right? So what in the brute force approach will will do some logic like this. Like we will iterate over, we'll start the iteration from 2 and till the number, let's say num, and we'll check. Let's say if our number is n, we'll divide the n by uh, num, right? Like first we'll divide it by 2 and check if we get any remainder or not. If we get any remainder, then that number is not completely divisible, right? If we get 0, then the number basically like 2 will completely divide it and we won't get any remainder. So that is the logic that we are going to try. For the next iteration, we'll try to divide by 3 and check if we get any remainder or not. If the remainder is 0, then it is not a prime number, because the number, like the iteration number, like 3 or 4 or whatever number, it is completely dividing the number that we have inputted here, right? So that is the logic that we are going to code this problem with. So let me start. Before starting, I like to take a boolean variable here called is prime. So we are going to establish some belief here, right? So the belief is that the number is prime, and we are going to set this flag is prime to false if we meet the condition that I have explained. Like if it is divisible by any of the numbers, then we have to set this flag as false. Okay. So basically we'll be starting with 2, right? Because the number 1, it's divisible by each and every number. So we'll start with 2 and then we'll go to the number. Okay. So we have to go to the number. So we have to go till array of I, right? And this number will be excluded, right? Because the number will be divisible by, let's say 5, it's divisible by 5. Okay. So we have to check if, what do we have to check? Yes, we have to check if the number which is input array of I, is it divisible by j? Okay, and if it is divisible by j, we'll get 0, and then we set the is prime flag to false. J. Otherwise, we continue with the iteration, and once we get the is prime flag false, we'll break out of the loop because we don't want any further iterations. Like let's say we start with 6 and we start with 2 right here. Like the first element of input array is 6. Then we'll start with the iteration with 2. If the number, the pointer will come here, it says 6 mod 2. 6 mod 2 is equals to 0. And then we set the is prime flag to false. And then we directly break. We don't want any further iterations after that. Okay, so after this we need to print if there are some certain conditions, then we have to print. Okay, I like to use the ternary operator here. So I like to do this kind of thing here. where we give the first condition, which is if num, let me check what is the num that we get here. Input array is equals to true, or input array is equals to true, or is prime is equals to is prime is true, then we have to print prime, right? Else to print prime, else we have to print, oops, my bad, not hyphen prime. Key. So we'll, let's go over the logic again. Like we take an array of inputs, we store them in an input array, we iterate over that input array again, and we try to find if the number is prime or not. Okay, we try to do this by iterating over the array and checking from 2 to that number if any number divides that number. If that number divides that number, if any number divides the number completely, then we will get the mod as 0. Okay, so let's try run as Java application, enter a number, let's say I enter 3, and then I do enter a number which, let's say 4 first, and 2 first, and then I'll check for 7. Okay, so the output that we will be expecting is not prime, 2 is prime, right? That's where we have handled this condition. And then 7 is prime. Okay, so the output should be not prime, prime, prime. Let's see. Yep, that's what the output is. Okay, so this was the brute force approach that we followed here, right? So let's now try to optimize this. So let's first try to calculate the complexity that we have, the time complexity that we have here. So let's say I input the array size as array, like I want to check if 100 numbers are prime or not. So I input a number here as 100 and I take 100 inputs, which will take time, right? To iterate over all those 100 inputs. So we will have to iterate over that array first, and for each of the element in the array we have to iterate from 2 to that number itself. So let's say we have n as the array size here that we have, and then we have key as the input number that we have, which is the largest. So the time complexity for this will be n times k, O of n times k, which will be considered like O of n square. Okay, so let's try to minimize that. And how are we going to minimize that? Let's discuss that. So let's consider the number 6. So we'll be having the factors for number 6 as 1, 2, 3, and 6. Let's consider the number 12. Okay, let's write the factors for this 1, 2, 3, 4, and then we have 6, and then 12. So how do we get those factors here? So let's try to write that 1 times 12. Okay, my bad. 1 times 12, 2 times 6, 3 times 4, right? And then 4 times 3, then 6 times 2, and then 12 times 1. So if we observe carefully here, let's divide this into 2. Like after these, the numbers are repeating, right? So 1 times 12 is same as 12 times 1. 2 times 6 is same as 6 times 12, right? So what we'll have to do here is we'll have to calculate the square root of the number. The first step. The square root of 12 will typically lie between 3 and 4, right? Because the square of 3 is 9 and that of 4 is 16 and 12 lies between 9 and 16. So that's a rough calculation that we have here. Okay, so it would be safe to say that if any if there are any factors of a number, they would appear before the square root of the number, right? So let's consider a non-prime scenario, right? So let's say 7. What are the factors of 7? 1 times 7 and then 7 times 1. Like we have these two as the factors, right? 1 and 7, the number itself. What will the square root of 7? So the square root of 7 will typically lie between 2 and 3, right? Because square of 4 is 6, square of 2 is 4 and that of 3 is 9. So and 7 lies between 4 and 9. So yeah. Mm, so there are no factors like of the number between uh, 2 and 3, right? So that is why we have 7 as a not prime number and 2 as a 2 or 12 as a prime number. So the logic that we'll be following is that we will first try to find the square root of the number. We'll iterate till the square root of the number. Let's say num. And we'll check if there is any number which divides the square root of the number. We'll follow the same approach. We'll start our iteration from 2. The only difference here is that we will be iterating till the square root of the number. Okay, because if there are any factors of that number, they will appear before or on the square root of the number. Okay, so that is the logic that we'll be following here for a more optimized approach. So how do you find the square root of the number? So I can do a math dot square root here, right? We have an property here, maybe I think square root, right? But instead of that, what I'm going to do is I'm going to square on both sides. So I'll take j times j. Okay. And what will happen is that if I take square on both sides, the square root symbol, it will go. Okay. So that is the approach that we will be following, and let's see. Let's try to run it now. Okay. Let's go over the logic once before running. Okay. So we are establishing a belief that the number is prime first, and we try to contradict the belief, right? So we'll be iterating till the square root of the number and checking if any number from 2 till the input of that number is it is that number making is that number divisible by the input number that we gave. So let's see. I input 3, input 4 times 2 times, let's see, we want a prime number now. It is 7. Oh, oh, we have got a wrong input. Okay, so typically we have to iterate till the input array of I, g times j. Okay, so 4. The problem is that 4 is not a prime number, but still we have got it as prime, the other two are as non-prime, right? Okay, so let's try running it once again. Not sure why we have got the 4 as not prime. So 4 will come between here, so it will start with 2, right? 2. Okay, so we missed this equal sign, right? So it will directly come here, 4 will directly come here, skipping all these iterations because 2 times 2 is 4, 4 is less than. We didn't have this equal sign. Okay, let's try now with the same input, 4, 2 and 37. That's right, we got the output as expected. So that's all for today. In the next video we'll be solving some more problems. So see you there.